Let's see, can you put 2 and 3 rounding as well around the order? That's just leave it here.
Oh.
Just need it to be,
Yeah, a couple places.
okay.
So if you wanted to, you could sort list 1. You don't have to. But it's actually kind of a good idea in general. And then I want to make L2 equal to L1 minus what? 6.5, I like it. So see how far each data point gets away from the mean. Some negatives in this stupid thing, so I got to square that. No, Jen. L2 squared. Bam. Alright, then on a quiz or a test, you would copy all that stuff down onto your paper. I'm only going to make you do that for a past test one. We're not going to do this one again. So now if I go second mode, I can get out of there and I can sum up. At second step, I can go sum up my list 3. Okay, so let me switch over to this. I'll tell you what, let me switch it over here. Alright. Somebody decent with the calculator? Anybody else want anything in the calculator there? I'm going to switch it over. Just make it easier on me. Go. Okay. Alright, so now, blah, 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 you fill it all in. You sum this up, you get 69 down there. If you sum these up, you should get 0. In this case, I didn't round the mean at all, so it's going to be exactly 0. If I had rounded the mean, it would be different. So for the variance, I'm going to get, what goes on top here? Divided by? Good, 12 minus 1. And why is that there? Why is n minus 1 not just n? Because it's just a poor little sample. Like, it's an adjustment because it's just a sample. That's really the way you should think about it, because that's actually exactly true. Mathematically, why does that exactly work? I can't go into. It's a little bit more. Later, we'll talk about it a little bit more. So what do you guys get for this here? Blah, 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 blah. So on your calculator, you shouldn't round anything. On your paper, you can round a bit. Then on your calculator, you do the square root of that business. And so what do you get for S?
4. So you would square that. Remember, it's
6.
7.
Square root that, yeah, exactly.
And
Exactly.
you get the standard deviation.
Yes. So when you just do this, that's the formula for the variance. And the little square on that symbol tells you haven't taken the square root yet.
Okay.
Then you take a square root. Now you undid all the squares. You don't have square dogs. You don't have square whatever. You have normal whatevers, right? So one thing I can do with the standard deviation is tell how far apart. So let me see you guys. If I was going to measure the distance from here to New York, would I use centimeters? Oh, you would all look at me like I'm crazy. And for 2 reasons. 1 is really small, and 2, it's metric. You know, the U.S., man, what's wrong with you? It's too bad. The rest of the world. We're the only country on the face of the earth now. The other 2 countries that didn't use metric, they're switching to metric. We're the only ones. And you can think one way or the other, whatever. Sorry. Okay, so I wouldn't use centimeters. That's dumb. I would use something relative to how far apart cities are, right? So the standard deviation is what I use. It's like the tick marks on my ruler. So when I want to know how far apart 2 data points are, or how far a data point is away from the mean, I use standard deviations to measure it. So the mean was 6.5. So 9, do you see how it's almost 1 step, 1 standard deviation up from the mean? Is not exactly 1, right? So when you do this, you're going to figure out exactly how many steps, how many standard deviations away from the mean it is. So my data was really tight, like it was 100.1, 100.2, 100.3. That's my data. I want to take little tiny steps. If I take a big ass step, I just miss all my data. So the standard deviation, I very often call it a step. It's how you step around your data. If your data is really spread out, it gets big. So I'm stepping around big time. If it's really, really tight, it gets small. So I can step around it, like that. Okay? So when you do this problem, x is the value of the variable, and I'm interested in 9. X bar, of course, is the mean. Standard deviation is just 2.504, and you should get 0.998, roughly. So it's almost one full step away. Something else we're going to talk a lot about is this idea. If I step out from the mean, after a couple of steps, I should catch a lot of the data, because a standard deviation is how far on average the data gets. So one step you'd expect to catch a decent amount. 2 steps you're going to catch a lot. 3 steps you're going to catch almost all of the data. Because one standard deviation is the average distance that gets away from the middle. So this is a very concrete example of theories we're going to talk about later. What's in the middle here is the mean, 6.5. If I add 2.504, what do I end up?
9.004.
9 point blah blah blah. And if I subtract 2.504, I end up at 3.9 blah blah blah. So often I hate fish. I don't eat fish, I hate fish. But I like the idea of you cast out a net and you see how much you catch. What data did I just catch? Did I catch any of the 2, 3, 4? Did I catch 4? Yeah, I caught all the 4s. I caught the 5s, 6s, 7s, 8s, and just barely 9, right? So how much of the data is that exactly? There's how many 4s? There's a couple 4s, 1 5. So how many data points is that?
9.
So 9 data points? Okay, so 9 out of how many? 12. And that is what percent? 75%. So 75% of the data is within one standard deviation of the mean. If you think about it, it kind of makes sense. If they on average get that far away, if I go one step out, you would expect most of the time to catch something. 2 steps out, you're definitely going to catch something. Okay, my God. So, Wednesday, of course, next Monday is a holiday. So this Wednesday, I'm going to bring a practice test with an answer key. We're actually going to work on it in class. We're going to make a formula sheet that you can use for the test. And we're going to see what questions you guys have. Try to get into this homework so you come with questions. Cool.